Okay, I know I skipped the problem on the previous page, but we're going to do that in class. I want to talk about tips about the correlation value R. So here I've provided you with 7 graphs and 7 R values. I want you to pause the video right now and see if you can match those correctly to their graphs. Pause! Did you draw the lines in first? Sometimes that helps. Pause again if you didn't. Okay, how'd you do? Did you get them all matched up correctly? So the positive ones, right, shouldn't have a negative one on there because they were going up, and vice versa. And you should have noticed right away that R equals 0 was kind of a hot mess. Those data values were all over the place. So some things to remember about R in addition to being able to match them up, and yes, it has to be a value between positive 1 and negative 1, is that it doesn't matter which variable is the explanatory and which one is the response. I can switch them and the R value will still turn out to be the same. And since I know you probably don't believe me, we're going to look at this tomorrow when we do the femur and humerus. Both variables must be quantitative, have to have numerical data to work with in order to actually do some calculations, right? Because I got to do z-scores. R has no units because z-scores have no units. It's just an average distance away from the center, so it's not in centimeters, not in meters, it's not in any type of unit. R measures a linear relationship only, so if you have curved data, it makes no sense to start talking about R. We will look at it when we are looking. The calculator is going to generate it for you, but it's not really going to make sense to talk about the strength of a curved relationship because R talks about strength of a linear relationship only. So it will not describe nonlinear. And that's going to come into play next chapter in chapter 4, which will conjoin with chapter 3. Also, R is very ticklish. Non-resistant. He's affected, he's tickled, resistant. He is tickled by outliers. So, if I have outliers, I have to be extremely cautious. Use extreme caution when outliers are present using R. And also, R is not a complete description. So I can't just say, oh, it's a super strong relationship. I must show the graph. I must show, what did I write? Complete description. I literally cannot talk and write at the same time. So you have to show your sofa and your graph and your line of best fit, which I'm going to show you how to calculate, and then your R value, and some other things that we're going to talk about still. So our least squares regression line, it is linear, so it looks very similar to what you've learned all throughout math, y equals mx plus b. They will use different variables. On your formula sheet it'll look different, and in your calculator it'll look different. You just have to remember this is still the same formula, it's just dressed up a little bit differently. So we'll tend to use ax plus b because that's what's in your calculators. Your formula sheet uses something a little bit different. Again, you just have to remember slope goes in front of x, and the y-intercept, of course, is off at the end being added. And so what it does is it gives us a line that's vertically as close as possible to all the points. And so I've drawn in some vertical distances here in green. And what it really does is it wants to minimize those lengths. So it's trying to make all those green lines simultaneously as short as possible. And a good rule of thumb is just try to make it go through so that you have about half of your data values on top and half of your data values on bottom, and try to get it to hit as many points when you're doing that as possible. However, unlike your R value, your correlation, the LSRL absolutely and positively requires that we know which variable is the explanatory and which variable is the response. If you get them backwards, you will have completely different equations, and one of them will not be correct.